All right, guys. The first lesson that we're going to talk about is angles, positions, and degree measurements. So we're going to compare these to a circle. And so most of you guys know that a circle has 360 degrees, but we're going to think about this circle being centered on the coordinate plane. So it's like you have your normal X and Y axis, and the purpose of these here are to give us two things. They give us direction and they give us coordinates. And then on here you have a circle. So there's our 360 degrees. Sorry, not so great at drawing circles. So we're going to talk about degree measurement around the circle. And you guys know a circle is 360 degrees. So you're able to figure out other measurements around the circle, like how much of the circle is 90 degrees and stuff like that. But in order for us to kind of land at the same place when we talk about that, we need an initial starting point. So this was just determined, and if you do it a different way, you'd be kind of creating your own math convention and it wouldn't kind of match with anyone else's. So here we need an initial starting point. So we consider this kind of our position of 0 degrees. And you go around the circle in the direction that you would go through the quadrants of the coordinate plane in order. So what I mean by that is this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if somebody gives you a positive degree measurement, you are moving this direction from 0 to measure that angle. Okay. So if they gave us an angle, we would have a certain measurement that we went from 0. And this kind of gives us two pieces here. So this green piece, always along this positive x-axis, is what we call our initial side. The red line that I drew, as if that was the end of the angle I was measuring, would be the terminal side. Okay. And this is an angle in standard position, starting at that positive x-axis. So we've covered, I'm sorry, you guys, we've covered standard position, initial side, terminal side. Okay. So let's say that this angle is 40 degrees. Okay. And it lands here with this terminal side. This next vocab word that you see here, these coterminal angles, means another angle that lands at the same position. So there's a couple of ways that we could look at this. Let's say that we went the other direction. So let's say that we traveled this direction, but we landed on the same place that we did previously. That would mean that these angles have a terminal side that's in the same position, which means they are coterminal. Because this angle went the opposite direction, it went this way around the circle, it's going to be a negative measurement. Okay? And this angle would actually be negative 320 degrees. And the way that I know that is because I know that 360 degrees make the circle, and that there's this extra 40 degrees that I didn't get to. So 360 minus 40 gave me the 320, and negative because it went the other way. So negative 320 and 40 degrees would be coterminal angles. I'm going to add another one to the list. Okay. If I went around the circle in the positive direction, but more than once, so I went once around and then landed here, that would mean I went an entire lap plus an extra 40 degrees, which would give me 400 degrees. So negative 320 and 40 and 400 are all coterminal angles, and there would actually be an infinitely many coterminal angles to 40 degrees, or any angle, because we could keep landing at that spot infinitely many times by adding or subtracting 360 degrees. So what you're going to be expected to do here, first let me touch on two other vocab words that we'll cover more later. First of all, central angle. That's that angle that we're measuring on the inside here. If in case you don't remember, for a circle, a central angle, before we put circles on a coordinate plane, but just from geometry, a central angle was any angle that went to the center of the circle. So all the angles we measured here, we're using the center of the circle, were central angles. And later in our course, we're going to talk more about this intercepted arc. But in geometry, your intercepted arc was which arc length of the circle that the angle kind of cuts out of the circle if you look at the two endpoints of the angle. All right, so example 1 is to sketch each angle in standard position. So this is going to take a little bit of estimation, but you should land in the right quadrant and kind of be somewhat in the right space in that correct quadrant. So 100 degrees, I would have, remember we're going to think circle and we're going to think starting position on that positive x-axis. I would have my initial side, and then I would know that 90 degrees is this much, so 100 is just 10 degrees past that. So I would draw it somewhere like this, and it's this angle in here. So that would be an example of an angle that could represent 100 degrees. For negative 215 degrees, I know that I'm going to go the opposite direction. So from the initial side, I'm going to go in this direction. Okay. And when I think about 215, I know that I should go through two entire quadrants and then partially into the other. I'm using some things to help me, like the fact that going all the way to this other line is 180 degrees, and that the difference between 215 and 180 is 35 degrees. So I know I just need to go an extra 35 degrees more than 180. So that would put me about there. That would be negative 215 degrees. Now we're going to look at it from the other direction. If someone drew the angle for you, could you say how much degrees that was? And some of them you would have to approximate, but these two here, we should be able to get exact measurements. So in this first one, you can see that the angle is going to be positive because it goes in this direction. Okay? You know it's in the first quadrant, so you should know that the angle is less than 90 degrees. So how much less? And there's a hint here. See how they tell you the side passes through 3, 3? That means if you drew a triangle back to the x-axis, and you know to get to this point you went 3 to the right and 3 up, that means you would have an isosceles triangle here, an isosceles right triangle, and that would make each of these angles 45 degrees. So the angle drawn in the picture is 45 degrees. For part B, notice that we are going in this direction, which means I know my answer is going to be negative, and it goes exactly through 3 quadrants, and each quadrant represents 90 degrees. So 3 quadrants of 90 degrees would be negative 270 degrees. All right, so the last thing on here says, which of the following angles is not coterminal with the other 3? So let's think about 750. So 750 minus 360 leaves us with 390, which means we could subtract 360 again, which leaves us with 30. So 750 is like 2 entire laps around the circle plus an extra 30 degrees. Okay, so it would land at that same marker as 30 degrees. The difference being that you went once, twice, and then an extra 30 degrees to get there. So it would definitely be coterminal with 30 degrees because 30 degrees would land at the same position. It just would have only gone right to that spot. So these two are definitely coterminal. Then I look at negative 330 degrees. So negative means I'm going in the opposite direction. 330 degrees would be almost the whole circle, and the amount that I would be away from completing the circle would be 30 degrees. So again, it would land coterminal with the other 3. The next number I have is negative 540, which I'm assuming is the answer, but I'm going to check here. If I go around 360, 540 is 180 more than that, so it would land over here, and you see that it's not coterminal with the other 3. Okay, so now what we're going to do is we're going to take angles that are special to us and label them one time around the circle. So the idea of angles that are special to us, okay, is angles from special right triangles, so like 30s, 60s, 90s, or 45s, 45s, and 90s. So things that are multiples of those angles, and we're going to put them on something called the unit circle. So the unit circle is a circle whose radius is 1 unit. That's why it gets to be called the unit circle. Its purpose, as you will see, is that it's like an organizational tool, and it's going to help you quickly calculate trig values of angles. Like sine of 30 degrees, you're going to know immediately. Sine of 210, you're going to know immediately without using a calculator. So you might think, who cares? A calculator can do it for me. And so when I ask the why, I would tell you guys kind of like our multiplication tables. A calculator can do 2 times 4 for you, but you've used it so much up to this point that it's important that you actually know what 2 times 4 is on your own. It would be very inconvenient to stop and use a calculator. That's how these trig calculations are going to be as you guys move forward to like pre-calc honors and calculus, that these are going to be like the building blocks of the calculations that you're going to go on to do in that course. So again, it should be like knowing your multiplication tables. So our ultimate goal is going to be to memorize this unit circle to be able to quickly calculate trig functions. Oops, sorry. So it's on the next page. All right, so here's our unit circle. Right now, it looks like what you guys had previously drawn for our angles. It basically has the x and y axis cutting through the circle. So this is your y axis up and down here. And then left and right, you have your x axis going through there. And then we talked about our conventional starting point that we start over here, and that would make that 0 degrees. And the other name for it would be 360 because you land at that same spot if you've gone around the entire circle. We talked about each quadrant being 90 degrees, so we're going to just label positive angles. So we're going to go in this direction. 90 degrees would be after you've made it through the first quadrant. 90 plus 90 would be 180. 180 plus 90 would be 270. 270 plus 90 would take us back to 360. So that gets us around the circle for each quadrant. Okay. Now, technically, you could mark infinitely many angles on this circle, but just like with your multiplication tables, you don't know them all. You don't memorize, 27 times 13. However, you have at least basic one memorized. Same with here. We don't want all the angles, but we do want the ones that are special to us. So 30s, 60s, and 90s, or 45s, 45s, and 90s. So in the first quadrant, when we look at that first 90 degrees, the way that they've positioned these lines, the angles that would be special to us that are smaller than 90, that would fall into those triangles are 30s or 45s or 60s. So this would have to be a 30 for us. This would have to be 45, and this would have to be 60. Only if we know that we're only labeling special angles and that's their position in that quadrant, that's what they would be. Okay? So that means this many degrees here is 30 degrees. That means this on this side is also 30 degrees. So the angle that's 30 degrees before 180 would be 150. And the angle that's 30 degrees after 180 would be 210. And the angle that's 30 degrees before you finish the circle at 360 would be 330. Then if I go through and look at the 45 degree angles, okay, so this is 45. The angle that's 45 degrees before we hit 180 is 135. The angle that's 45 degrees after we hit 180 would be 225. And the angle that's 45 degrees away from completing the circle at 360 degrees is 315 degrees. And then lastly, we're going to look at 60 degrees. So 60 degrees is this much of our circle. And so on this side, if I drew that same angle measurement 60 degrees, I would label that whatever value I would be at if I was 60 degrees away from 180, which would be 120. Here would be 60 degrees past 180, which would be 240. And here would be 60 degrees before I reach 360, which would be 300 degrees. So you can see, I'm going to erase the way I drew my references here. And we'll get to those another time. They're called reference angles. So you can just see the angles that we came up with. And so there are all of our special angles labeled on our unit circle in the positive direction. Okay, and so the goal of this lesson is just for you guys to see the angles, okay, understand angle position and some of that vocabulary, and to understand how those angles fit at least one time around the unit circle.